Hello and welcome back to compiler programming. Now that our P32 executable encoding is in a good shape, I want to try to stress it out a bit and make the program that we are doing slightly more complicated. I will leave out this small program that just exits with code 42 and rename the test to reflect that. So should write out an executable that exits with status code 42. And here we are just using one value. And what I want to do today is to try to make an executable that prints hello world. We already have a test like this that is working with the LibC, so we are just calling puts function and we are doing it at runtime. But for this one, I want to do it all in Win32 APIs. So there is no dependency on libc. And that means I can't use printf, I can't use puts, or I can't use any of that. I'll have to figure out how to do it with just those APIs. So let's first look up the APIs that we will need and look at what libraries are in so we can import them. I guess I will need get std handle. So this will give us like a file descriptor if you're in the Linux world. In Windows, they're mostly called handles. Basically, it's just an integer that will then get back to the system in the calls like write file and read file to be able to, get value or write value to standard out. There is also this read console and write console, but they are a bit more high level, and I want to go to like really basic things. So this is what we are going to do. We need this function, and we need to say get std handle value, and this I believe also lives in kernel 32. Yes, it also lives in kernel 32, so that's good. And the signature for it is handle, and then Win API and get std handle. Now, I don't remember what is the size of the handle. I believe it is a size of pointer, but we can figure it out rather easily. So I can just do printf %lu and say handle size is this thing, size of handle. And we can try to run this, and hopefully it will tell us what is the size. Now it complains that we are not using these two values, so that's good. Okay, so what is the error? Requires of type in64, but it has size t, so I guess it's supposed to be LLD. Okay, whatever, let's just do it this way. Okay, now what do you don't like about this? I just cut you to U64. What is the issue? Okay, let's just do it this way. Fine. Okay, let's run the test. And in here we say handle size is 8. So that means that we also leave it as S64, and we say get std handle. And what does it get? It gets in dword. And just to remind you, dword is 32 bits. So word is 16 bits, the word is 32 bits, and keyword is 64. At least I believe that's the case. We can also verify that by doing it like so, right? We have the same thing, and we can say d word and say d word. Okay, and then we just run this, and it will tell us exactly what the word size is. The word size is 4, yeah. So let's leave this commented out, and that means that the function is exactly the same as exit process. That's okay. Now, so we have this getStd handle. We will need to pass in std output handle for it to work. So let's create that value, and we say value star std output handle value is value from S32, I guess. Value from S32, and I can say that this is -11. Okay. So let's start writing our function. And the way it works is we need to say value star handle is going to be call of get std handle value with std output handle, right? So we'll need to make that call that returns the value. It also can return null. In reality, it will basically never return null to you unless you're doing something really, really strange or you're calling it from the wrong thread or something. So like realistically, this thing almost never fails. So I'm just going to ignore this. And once we have a handle, what we need to do is we need to call write file on this, which apparently, let's do it like this, this write file. And we need to have this rather complicated signature, which I don't believe we can parse right now. So this would be another thing to figure out, but we can do that. Let's just start by writing it, and then we will fix things as we need to fix them. Okay, we have a write file. It is also in kernel 32, I believe. Yes, it is. So that's good. And we now need to do this. So let's split this out because the signature for write file is rather long. Okay, write file. It gets a handle, which we already know is S64. It gets LPC void. So this is how you read this weird Windows type. LP is long pointer. So this is a 64-bit pointer to void, basically. To constant. C stands for constant and void is void. So this is const void star. In our case, it doesn't really matter. We can just replace it with S64 for ease of parsing. So that's okay. And then we have dword, which we know is S32. Then we have LP word, which is so it's a pointer to the word, and this is where we will need to allocate it on the stack. And I guess we will need like a temp value or something for this. I already don't remember the API for it. So temp allocate, no. I need something on the stack, and I guess I can look at how plus or minus implemented. And yeah, it's basically reserve stack. Okay, that's fine. Can do that. So we reserve space on the stack for the 32-bit value, and this is Descriptor S32. I think this is how we called it. So builder. Maybe we have a wrapper for the stack. I already don't remember. Yes, we actually do. There is stack S32, so let's use that. And we say that this is bytes written is stack S32, and what does it need? It needs an ID. Okay. So this is bytes written, and the value that we want to move into there is value from S32 of 0. Okay, now we can start figuring out how to call this. So this is also S64. We might need to provide a more specific type here, so we'll see how that goes. And then LP overlapped is so this is also a pointer, so this is also a 64. Yeah, let's see how we are doing with this. Return is bool, so that's I believe S8, but we can verify what is the size of Windows version of bool. Okay, and we need to also say call of, so we need exit process. This is pretty straightforward. So we do this here. We exit with status 0 no matter what. And another call is now to write file. Okay, so let's do that call. And we say call write file. So also we'll check if our encoding of operands is correct. So let's see that. Okay, what do we pass to this? Well, we pass in the handle. We pass in the buffer. This is gonna be interesting. So here is me buffer, which is something I guess also that is not ready for us just about now, because we need to we will need to pass in hello world in there, but right now we don't have hello world anywhere, and since we can't just point to the memory that we have inside of the test like we did in the one that was using JITted version, that means that we need to somehow allocate that memory and stuff the string hello world into there. Okay, a number of bytes to write. So this is also we'll need to do like count. This was the static array size, right? Which we were previously using, but we need to figure out what it will look like in the new world. And LP overlap, this is actually easy. It is 0. So we say value from S64 of 0. So let's see. Right now, I will replace these two things with zeros. So technically, it should be a valid call to say that we want to write 0 bytes, I believe. Actually, I missed number of bytes written because that is the address of this stack, right? So this is buffer, this is size, and this is LP. Let's just sort of annotate this stuff so it is easy for us to remember what we were doing. So this is LP overlapped. This is a number of bytes to write, and this is LP buffer, and this is H file. Okay, so this one we must provide, and I don't remember, is it like pointer to, so this is descriptor pointer to, do we have value pointer to? Yeah, it looks like we do. So I think this is gonna be like so value pointer to bytes written. Okay. I guess I need to provide a builder. Okay. Good. So this call should technically work and not do anything. Let's see how it turns out. Let's just run a test. First, okay, so we are crashing somewhere, and that is then something we can try to debug. The thing is, write executable actually we don't provide the path, so we are ending up creating the file at exactly the same location, which is not great. We need to add the parameter here it will tell us where it will be written out to. So let's do that. So this is gonna be like so. And here we say file path. And for now, I will just make it Windows API, and then we will figure out how to make it better. Okay, so this one will be written out to build hello world. Okay, let's try to run the tests again. Okay, the first thing is return is actually S32 because bool is apparently 32 bits wide. But we are definitely crashing. So let's open up debugger and try to figure out what is going on. Okay, are we on the right thing? We are. So let's just start and see what is going on. So read access violation means that these, one of them is a bogus pointer. So B is totally fine, but A isn't. And I guess I know what is going on. It said we can't really parse correctly right now multi-arguments, if I remember correctly. So let's check that. But regardless, it shouldn't be really... yeah, so this thing is also busted. we shouldn't try to, we are basically indexing outside of an array here. Argument count, yeah. So let's fix that first. So first we shouldn't crash here. And the function name is, whoops, call function value. Yeah. This actually is fine. I'm not sure why fix me is here. Well, okay, for now I'll leave it. The thing is, this is a linked list of functions, if I remember correctly, yes. And we need to say that if argument count is, I'll just say it this way. While guess like so. So basically we want to skip this loop, but we still want to do this. So I guess I will change it into a for, and I will say it like this. Okay, so we can remove this stuff, and now we don't need to increase the indentation label, and we say that if argument count is not the same as this argument list, I'm not sure what is the type of it. I guess this is just a plain array, so we can say descriptor argument count. We just continue. We don't need to consider this as a valid overload. Okay, next overload must point. So this is slightly longer. Okay. Let's try to run the test again, and I think now we will see that overload not found. Yeah, no machine overload found. This is better, and this is exactly what I would expect to happen, because as I mentioned before, we don't really have correct parser for functions with more than one argument, but this is something we can try to fix right about now. Let's go to the very bottom. We have this funky code to parse this, and we can figure out what is the right way to do it. Okay. So yeah, we have the code here to deal with the function, and in particular to map register to the right thing somewhere. So what does func do? It calls fn arg, and this is what I want to be using, I guess, as well. So let's start changing this around slightly to be able to reuse this code. Next argument index, and then stack stuff. We don't really care about these things, I guess, although maybe we do. Let me think about this for a second. We do care about these cases, but I'm not sure we care about the stack case. Let's do it this way. We say function value for argument index, and what it will get is it will get an index, and it also will get a descriptor, or maybe first descriptor then index. And what it will do is it will do this stuff. Okay, let's rename it to argument index. And what is this function? Yeah. Let's take this out as well. Is it used? It returns this stuff. That's fine. We can still take out this thing. So it returns, what does it return? It returns the value. Well, let's continue to return the value. That's fine. And we can probably change this stuff around to return that value. Yeah, that can go here as well. And now we can say value star result is function value argument for index. We pass in the descriptor and we pass in next arguments index to here. And we just return the result. I guess we pass in this thing. I know we pass in the saved one. Okay. Byte size. This is only used here, so we okay, we need the function. And that's fine. And maybe let's rename this to argument descriptor to be more precise about what we are talking about. And use it like so. Okay. This the offset. Okay, offset, that is easy. And byte size we now have. So let's recheck. Yeah. I guess we should accept another argument, which is going to be function descriptor. And we say it like this. And we remove this stuff from here. So this is going to be back over here. And we pass in like so. Okay. I'm okay calling it just function. Good. So let's try to run tests. I expect that nothing really changed much, but nothing changed is also a good thing for us. And maybe I would even temporarily disable this test and try to run it again to see that I haven't broken anything else. Okay, so the way I extracted the function is perfectly fine. And that means that we can probably rename it a bit and move it out to the value. So let's take this stuff out and move it to here. Okay. Cool. That means that now we can take this function and start using it in our parsing code. In particular, we can say that, yeah, value for argument index. We don't actually really need that value, but this will also change the descriptor. So we need to pass in the function that's going to be descriptor function. And then we need to pass in we need to pass in the descriptor for the argument. So this is argument descriptor, and we need to pass the index, which is for now 0. Cannot convert. That's okay. Let's see if this is better than it was before, or at least that shouldn't. Right now, it shouldn't just break stuff that we had before. So again, I will comment this out and see how we are doing. Unfortunately, that seems to be a bit problematic. So let's try to see what is going on. And I think I do know what is the issue when we create this function. We don't really, it's basically 0, but here it needs to have arguments, because if we have function begin, then we allocate 16 arguments for an array. Okay, let's try again. And we don't have a matching overload. This shouldn't really happen. So something is still quite screwed up. Let's try to debug this a bit. This happens into function spec at the very first thing. So that means basically that this test is failing. And that means that parsing of this stuff fails. Let me check what happens here. So let's copy this just to be sure. Okay, still failing. Let's debug. Parse C type, C function descriptor. Okay, so let's stop here and figure out what is going on. What is argument descriptor? Argument descriptor is integer of byte size 4. That seems correct to me. Descriptor type, yeah, descriptor type is integer. So that's okay. What is a descriptor function? Argument list, it points to some list, which is empty. Yeah, that all seems perfectly fine to me. So let's try to step into this function and see what is going on. So we go through here, descriptor byte size is 4, that's fine. And we end up putting it into the zeros argument, that's okay. We return this stuff. So what is this full descriptor? Descriptor type is function. Then we open the function We don't increase the count of arguments. Who does that here? Function arg. Does it happen on outside? So we have this next argument index, and we have update result. Is update result doing that? Yeah, this is I want to move that from here. Maybe I will keep it for now in both places, or maybe I'll try to move it right away. So I want that to happen now in here, right? We need to say that we are making it one more, and that way and that way. Okay, still have this commented out, so let's see if this is better. Okay, cool. So let's add it to git index. Now we done our refactoring, which means we are ready to continue. So here there is no more hard-coded thing for 1. Instead, we need to do something about this stuff. Okay, what does this do? Well, I guess we just need to do this inside of an array, and we already should be going through multiple arguments. Let me try to stop at the right place. So if we go to function spec and we stop right over here and we run, and then we for some reason can't stop there. So let's try that again. 5. Okay. So let's step into C function import. That's fine. Yeah, this stuff is okay. Let's just run to here, run to cursor, and then we step into C function descriptor. Okay. Good. We get the return value. That's fine. And now we start parsing arguments. Okay, we get the first comma. We are not at the start. We parse the argument, and argument descriptor is this argument descriptor S64. Okay, what happens next? We continue. We start parsing the second one. We again get S64. Here we should get a different one. We should get S32, so integer, yeah. Okay, so the actual parsing is sort of working. We are just not using it in the right way. And this is pretty easy. We can just say that S34 argument index is 0. And when we find it, we just say this stuff, argument index, and we need to increment argument index over here. Argument index. Okay. That sounds good. Let's see if this is working better than before. Okay, we still say that there is no matching overload found, but that might be okay because I'm actually giving the wrong type for the for one of the arguments, or actually for multiple arguments. So let's see how we are doing. I guess we actually do support void star. So let's change that to be void star here. This parameter is void star. This parameter is technically also void star, but it is easier for us if it is 64-bit. Like all of these implicit conversions, this is something we definitely need to figure out, especially for constants. So right now the type of this expression is integer, but it should be something like a known constant type that just has an integer inside of it. And then if we see that it was a pointer, then we probably can cast, or maybe we want to explicit cast a pointer. I don't know. For now, I just want to make this stuff work, and that will be fine. So let's just recheck the types. The type of handle is correct. It is 64-bit. The type of buffer right now is also correct. Number of bytes to write is actually incorrect type. Okay. So this was a problem. This is a pointer. So let's see how that goes. I might have to change the parsing code for pointers. So let's figure that out later. And then we have 0 here. Yeah. So we either right now will need to change the code that deals with the type comparison and allow pointer to void to be accepting any pointer, or we will need to change the type here, but we'll see. Okay, let's do the test again. And I want to know what was the resulting type of this function. So let's make a breakpoint over here. Oh, that's fine. We can use the same one. We just step over this, and then we can take a look at our parsed write file value. Let's see what we have there. So it's descriptor function. Well, it correctly says that there are 5 arguments, so that's good. And now we can need to somehow change how that works. So let's just say that we want, can I add it to like watch or this? Add watch. Okay, that's good. Can I say to you what is the size of that list? Apparently not. Okay. So let's do like this then. The 0th one is register C. It is byte size 8, so that's correct. Let me maybe make this window even bigger. So, okay. We now can check the first one. This is also 8, which is, I believe, correct. So we have 8, 8, 4, 8, 8. Okay. Next one. It should be 4. Okay, that's fine. And then we have pointer type. Yeah. and it is a pointer to void. Okay, that's correct. And then we have what? We have an integer rate. Okay, so the parsing is actually fine now. The problem comes when you try to call this. So let's get to here and then step inside of this call. This is not what I wanted to have. So I have a bunch of values here. Then we have this one. And one more value. And one more value. And even more. I have a bunch of pointers here. Yeah, I should have probably extracted this into a separate thing. Yeah, it's actually because of the way our call works. So this is something to change, I would guess. Damn it. Okay, let's start again. We do a 5. We go to here. And now we will go to here and say, yeah, and basically stop on this breakpoint. Cool. So let's try to see what is going on. We have Descriptor. This is what we are trying to call, I guess. Yeah. And for the argument count, it is 5. Argument list is, well, the first one is correct, but the other one is not. So yeah, I'm pretty sure that our problem lies in this function. Same value type. And let's see if we need some special case. Yeah. So the special case should go into here, and what it is that we need to check that if we have a pointer to void, that it can be the same thing as pointer to anything else. I believe we have this same type. Yeah. So let's just add one more test into here. Yeah, should say that S64 star is the same thing as the void star. So this is S64. This is void. Right now the test should fail. Let's check that. And it didn't because I was wrong. So yeah. We have the test failing. Now we can fix it and say that if a pointer to type is descriptor type void, or viewpointer type is void. So basically it doesn't matter on which side you have void, they will match. You can pass void to anything, and anything can be passed to void star. So let's say that return true. Okay, let's try to rerun the tests. And we are getting better. Now, it looks like now we are failing inside of our P32 encoder, which is also fine. We can debug that. Good. So what's going on? Remove this breakpoint, remove this breakpoint. Okay. We are checking that the occupied stuff is expected. So we expected C8 and actually got a 0. So we estimated way more bytes than actually happened. I guess that is generally fine, but it is curious and tells us that there is probably some issue with the estimation here. Something happens too many times, whatever. So for now, I will just say this and to do check the math. So as long as this code, it's technically okay, because we are using the actual occupied things and we are estimating to reserve memory, but it is still suspicious that this is not matching. Okay, let's continue. Okay, so we are getting further on and it's now failing in a completely different test. And more precisely, it fails in a test that deals with 5 arguments, I think. So let's check that one out. Actually, it is failing here, right? Yeah, so this one is succeeding, but this one is failing. So what is going on? I think it is this thing, which needs to be special cased. So what's going on is in C there is this. In C, if you have a function and that function does not specify any argument, that actually means that you can call this function with any arguments. It doesn't matter. If you want to say that my function actually doesn't accept any arguments, you say void in braces. And this is a bit yucky to deal with. I guess I will just hack this in somehow and then figure out what is the right way to go about this. So what happens is we parse this stuff, we get void from argument descriptor, and then we need to say if argument index is 0 and argument descriptor type is descriptor type void, then we break. And I can make a comment that support for full void function signature. And actually we can assert that star ch is this. So we don't want to have like void comma and something else. This is invalid argument. Like you can't have void argument. You can only put it as a single thing in there. So let's check that. And we are good, at least as far as all the previous tests are passing. We are successfully encoding our program and we can try to run it and see if it works or not. Well, it does something. So error level. Okay, so it did finish. It finished without any errors. So this write file didn't explode or anything. It was all perfectly fine. But we are not actually yet writing hello world. So that is the next thing. And I believe we have this global, very global helper. That is what I want to have. Okay. So we need a string, and string is a bit tricky. Let me mark this stuff and I will search for hello world and see if we are doing it anywhere more or less correctly. Yeah, so this version is actually closer to reality than anything else. Okay, for now I'll inline this here and maybe we'll add a helper for this, but let's see. So it is a fixed size array. And here we now need to change the type to be void star. So it's also something to figure out. Same type. Yeah, so if one of them is fixed size array, then it just recurses into itself and everything is fine. Yeah, that's okay. So we have this message descriptor, which will be fixed size array. And we need to do stuff with it. So the first thing is we need the actual value. Let's share hello world string. We say hello world. Now we want to say u64 hello world length. Length is strlen of hello world string, and this is going to be here. I mean, we technically don't need this to be fixed size array, but I kind of like if it is going to be. So let's keep it that way for now. This is a descriptor, and we need an actual value for it. So let's do that. Value star message value is value global. And what do I need to give it? Value global. I need to give a program and descriptor. That's fine. We can do that. So we have program and message descriptor. Now we can put this here. So we are passing the message, and here we can do this conversion. So this should be actually S32. Let's, and this is +1 because there is also 0 byte at the end of here, and we want to account for it as well. So this builds, but it doesn't actually do anything because it doesn't So this allocates, that's fine, but it doesn't actually write that value where it's supposed to go. So we need to do that. Where is another example of reap so I don't have to do anything? Global value. Okay, yeah. So this is what we need to do. A lot of what I'm doing here, like this, for example, this kind of pointer writes, this is not how you're supposed to be doing it long term, and we will probably clean it up eventually, because right now I'm assuming that we are running the compiler and the actual function code on the same architecture. So that means that the same word size, the same endianness, little endian versus big endian, and so on and so forth. So like all of this needs to be eventually cleaned up, but that is a separate topic altogether. So, and this needs to be cons or char star. Char star. And now we're just gonna do copy of to this address our string, and hello world length. Okay, that is better. That works. But if I now try to run this, best case will get garbage out, worst case will crash. Let's see which one it is. And we got no matching overload found, which is not exactly what I would expect. Let me think about this. Is this fine or not? So this fixed, yeah. So it actually needs to be a value pointer to. So let's extract actually this stuff and say value star bytes. I said star bytes written pointer is this thing, and then we have message pointer is a value pointer to message descriptor. Cannot convert, yeah, that's fine. It should be message value. Okay, and now we are putting this thing here. So now it should match the types, I think. Okay, we're not actually calling it. That's also, okay, that's interesting. So we are exiting. Let's see what is going on there. So we are successfully exiting, but we are not printing anything, neither garbage like I would expect, nor real thing. Okay, well, it's time to figure out what is the generated assembly for this stuff. Dev env build hello world. Debug step into. This is gonna be a bit tricky to follow, but we can try. So this is stack allocation. This is our minus 11 for std out handle. This is something we can actually verify just in case. msdn std this thing. So std output handle minus 11. Okay. So this should be fine. We can even verify by putting it like minus 11 of int. Yeah, so see this FFFF and then 5. So this is correct. We are putting it into the thing. We are putting the address of get std out. We are call rex. And right now the result is in rex. There is not really a way for us to verify that this is indeed the correct result, but I guess it is. I guess we could try to call it in the main program and see if it gives us the same value. But I assume it should be. Okay. Move this. So this is just saving the result to stack. This is a 0 for our bytes written. Then we are loading the address of at the very start of data section, and this is something that we need to fix right now. So this is, I guess I want to see what is that address. How would I do that? I guess I can try to say that I want, I want to convert these to const char star. Well, it cannot read characters of string address, but can you show me? So it can't read that memory at all. That's interesting. So yeah, that's actually wrong. This address is completely wrong. Okay. Let's think about what's going on. In particular, I will need to look at our encoding code and see what happens for the reap stuff. So start address, buffer memory. What are we using start address for? Yeah, this is just wrong. This should be like this. I will keep this stuff for now, and then I will try to run the tests now and see if it works. Although now we have a problem that it will not allow us to build. That's kind of unfortunate thing with Visual Studio, I guess, that I will have to close all of this out and we'll have to start over again. Okay. Let's see if this still passes all the other tests. Ugh. Not really. So what was it before? We would start at buffer memory and then we would go into start address. Okay, let's bring back debugger. And what I want to do now is go to encoding and see the first thing here. So let's try this out. And I want to compare program code base RVA with, so this actually is not the interesting case, I guess. Let me think about this for a second. So what fails is the case when we are doing it for the others. So this is next instruction, div operand immediate 64. Yeah. This is also incorrect, even for our executables. So the way this is supposed to work is we have virtual address of the some location in the data segment or data section, and then we have some address of the next instruction, and we just diffing them. But here, when we are doing this stuff, we are getting the absolute address of, so absolute offset in the memory. But what we want to have is virtual address. So somebody will need to do this translation, or alternatively, in here, we would need to be saving an offset into data section. That way, we can pass to the encoder the offset of the data section, pass in the offset of this operand, and it should be fine. How do I want to deal with this stuff? I guess let's just start making it happen. This will break a bunch of tests, but we can figure this out. So first of all, I want this to be S8, and then I would say S8 offset, or sorry, S64 offset in data section is address minus program data buffer memory. Now I will do assert fits into S32. Now that actually doesn't really matter. And I will put this stuff into here. So whenever we will create a rep relative value, I'll also change this name so I can track who uses it. Oh, I guess it is defined in the header file. No, we should decode. Operand. Rep relative import, that's fine. But here I also want to say S64 reap offset in data. Or yeah, reap offset in data. Sounds fine to me. Let's get back to here, and this is what it's going to be now. Okay, data buffer dot, that's okay. So this one also, this is a relative import, that's okay. This is fine, except it's fix me. Calculate with offsets. I'm not gonna deal with this one now. This is fine, and this one is just changed. Let's check if we have something in here. We don't, but we probably do have it here. Yeah. So this test needs to go. It will be, needs to be fixed later on. And this is the only test that actually was doing something with this stuff, I guess. Okay. We still might have a few tests failing, but my job right now is to make these two paths, and this is it. Okay, now we can go back to encoding and figure out how it's gonna happen. So we have a program code base RVA, but we also need to have a program data base RVA. So operand, what did I call it? Reap offset in data. So we need to say something like S64 operand RVA is program database RVA plus this. And this thing will be set to some absolute address for JIT code and to be set to virtual address for the executable. And now we say that something like this. Okay, we don't have database RVA, that's fine, but we also need to have operand. Yeah, so where's our program? Program is in here. We need to store this as this stuff. How does this work actually? This needs to be S64. Okay, we'll figure this out. Database RVA, that's good. And in I mean, it can be S32, I guess. It doesn't matter right now. We check at the end anyway, like we have this check here that the size is correct. So we need to fill this in, and we need to fill it in two places. One is program end, so we stuff this thing here. Yeah, okay, this is where we check for the offset, and this is okay. Okay, we here already give the diff to the data stuff, so we don't even need this extra value. Like, this is not necessary, because we can just assume that it is on 0. That means that we can use this stuff directly. So we treat offset as a relative virtual address, and because it's before, it is perfectly fine to do that. That's good. Let's see how we are doing now. Okay. access violating writing address. Yeah, that's fine. I forgot to fix this stuff because now it's no longer an address. It is just a offset, which is called reap offset in data. So I need to say program data buffer dot memory plus this, or I can do it this way as well. Doesn't really matter. Or I don't know. This is address. Let's check that. That should be better. Start. Okay, we were able to copy it. Actually, let's check it. Yeah, so now, as you can see at the very start of data buffer, we have hello world string. So at least the copying was fine. And now I'm interested to see what is our diff. This looks okay-ish, I guess. So that seems fine to me. And well, I guess we'll see if that is okay. Let's just hit continue. And yeah, this stuff we will fix a bit later. So should be able to call imported function. Let me just comment this out for now. Yeah, this needs to be fixed. Let's just remove this and add a fix me and try to run the tests. Okay, the rest seems to be fine, so that's good news. Let's see what we have now. Now, I actually would expect to see trash in the output when we try to run our hello world example. Yeah, so that is pretty close to what I was expecting. It prints out the very start of the file, which is actually incorrect. It should be printing out. Let me think about this. So here we have code base RVA, and then we have. Let me get back to this function. So what we are doing, code buffer minus data buffer. Yeah, that's. I'm not sure that is correct. I think we end up doing different things inside of P32 and inside of runtime code. What am I setting RVA here to before I'm doing the stuff? I'm setting it to the virtual address. And instead of setting it to the thing. Yeah, I guess we do need the database RVA after all. At least for now. So S64 database RVA. We'll essentially just defer what was happening before in here. So I will not do this stuff. Instead, I will just keep both of these as S64 so we can stuff pointers in them. And then I will do this calculation at a different point. So let's do program code base RVA is gonna be now program data buffer memory. I guess we'll need to cast this to S64. And then database is, no, it's like this. Yeah. This is where we store code, this is where we store data, and we let the other part, which is encoding, deal with the difference. So we can say S64 operand address array is program database array plus this. Okay, we are not using it. It's supposed to go into here. That's good. We are still not using this in here, which we need to. So when we are encoding this, we need to say that this goes into here. Okay, let's run this. We still have everything working. And if I try to run this, I expect different garbage in output. Okay, this is good. This is what I would expect roughly to happen. And the problem right now is very simple. So we are outputting exactly how many bytes we said we need to output for the whole world, but those are the wrong bytes. And the reason they are the wrong bytes is because we are, when we do encode our data section, we are not actually taking into account the data that we have already there, right? That we accumulated. So we need to do that. And the way we would do this, well, first of all, we need to update encoded size and say expected encoded size plus equals line U64 of program data buffer occupied to 16. Yeah. So this is something that just so the reason this needs to be aligned is because we should avoid unaligned access. In general, we have it in a bunch of places, but we need to start to clean it up. So we do it right away here, and this is just any global values that we have written into the data buffer. They are there, so we need to know how much is there. Now that we have done this, we need to write them out. So let's create a variable for this, and we say U64 static data or global data size is this. We add global data size, and here we say void star global data is buffer allocate size buffer global data size. Then we copy the memory to this global data from the program data buffer memory, and the size of it is this thing. So we potentially allocate more because we align, but we only copy the actual bytes that are there because there is no guarantee that the buffer will have enough bytes for our aligned size. And finally, we need to, I guess buffer allocate will move this thing for us, so we don't even need to do anything else here. Okay. Let's try to run the tests again. they are passing, and now the moment of truth, we try to run hello world. And here we go. We have hello world written completely inside of our code. There is no dependency on libc, there is no dependency on anything. This is pretty much the smallest hello world you can do on Windows without doing anything crazy with trying to pack the sections. So there are all of these interesting ways how you can like try to overlap sections of each other and so on. You can even shove the hello world, I guess, into the code segment or something like this, but those are really weird things that you should never be doing with your actual program. But this is like, even if you're writing assembly, this is going to be probably the smallest executable you can get, and you can even check like how big it is. So let's take properties. It is 1.5 kilobytes, and it has 4 kilobytes on disk because disk actually allocates in the blocks of 4 kilobytes. So yeah, this is pretty cool. We have nice stuff. Just to verify that it's working like we want it to work, we can, add more stuff here and have it more. So that's great. That will be it for today. Off camera, I'll probably go and fix all of those tests. There is nothing really fancy there, just a bunch of straightforward code. For now, that will be it. I'm super happy we made our hello world work, and hopefully I will see you next time.